here's all the wire that I just took out there. We took that fat white wire out. We have 3 circuits now, so we have our line coming in from our battery right here, coming in to this bus bar right here, and then going across. So we have 3 circuits with three fuses on it. Pretty much is stock, just with that white line being repurposed. That was taken out and removed and then put back and brought back over here. Replace that fat white wire with a more appropriate wire, so it matches the this right here. So I also put some markings on it to make it match. So that's our official white-red circuit. And then our white-green and our white-yellow goes out this way as stock. And yeah, so this is what it looks like here. It took out about 50% of the wire. Got this all kind of done now as far as removal. And so now eventually we'll come back and hit it with some of this stuff right here, the wiring loom, to tidy it up. But that will come later on. First we want to go ahead and start attaching stuff, and we want to finish up as far as building stuff. And probably the last thing we'll do is come back and do the loom. And now we're going to go ahead and put the heater in, and this is just basically a booster heater. So the idea is this is not the total heating system. The primary heating system is the chill plate coming out of the controller. That's going to empty into the heater core. That's going to produce heat. That's going to be the basic heat. And then we're going to have seat heaters. And then when it gets even colder, we have the rear defroster that's still functional. And then we'll also have this little booster heater. And so what I figure is that on a cold morning, when the windows are fogging up and stuff, this would be enough to defog the windows, hopefully. So that's kind of what this is about right here. So what's nice about this is it's not a $1,000 heater. It's not a $100 heater. It's like about a $22 heater. So it's pretty cost effective. And actually I got the box right here. So the funny thing about this one, it says, well, it does say it's 12 to 24 volt. So that might justify why they say it's a 260 watt heater. But you know, I bench tested it. You know, it puts out about 153 watts. But that's at 12.8 volts. So, you know, it may be at 24 volts, it would put out 260. But in this application, I figure even when the DC to DC converter is at full speed, it puts out about 13.8. So probably, this will probably come up to about 13 amps, maybe 170 watts maybe, is about the most it's going to draw. But I actually tested it out, and so like I did put my hands in it. I mean, it felt pretty warm. I mean, it felt pretty significantly warm. So hopefully it's enough to kind of just take the chill off on those icy cold mornings. And so basically what we're going to do here is we're going to install it right about in here. I don't know if you can see that. Pretty much where the intake is on the blower fan here. You know, sort of existing. It's going to go right into our ventilation system. We used to have the AC inner chiller box area was right here. So all that's gone now. And then we have our fresh air intake right here, which I still have to figure out if I want to keep using that or not. That's kind of an option here. I'm not sure. We'll have to kind of play around with that if we want to have that or not. I might just block it off and have everything recirculate. Maybe just open the windows if you want fresh air. And then so the other thing the other thing that's really cool about this whole thing, so this is one of our circuits. This is going to be one of our simplest circuits. We're actually going to be reusing the radiator fan circuit. So I've cut the wire because we don't have the fan, of course. And so this wire, we're actually going to be reusing the wire. So we're not even going to be adding any wire to this system, which is super cool. And we're also going to be reusing our radiator fan relay too. So all these things are already color coded. So this is the sweetest thing ever, because it's going to be reusing all parts off the car. So like for example, we have our blue and green wire. This is exactly how we're going to wire. We're going to mend it right back together here. And that's going to be our heater, and then that's going to be our power lead coming in, and then our other wire over here, the blue and red, this was what went to the fan, radiator fan in the front. Now it's going to go to our heater, so we're going to plug right into our heater, and then the switches for the relay are going to be going back to our AC button, which we'll relabel. We'll have to come up with a name, maybe a booster heater or maybe a turbo heater or something like that. Have it say turbo, the little turbo button or something. Something like that might be kind of cool. So we'll have to relabel that. but we're going to be able to reuse that. So the light will come on when that kicks in. So like we'll have a regular heat that we can kind of adjust. That's still going to be fully functional because that's purely mechanical, and we'll still be able to adjust the heat that way from the controller, whatever heat amount that produces. And then our booster heater would be a separate circuit that has a little fan on it that will do that. And of course the fan still works, all this still functions properly. And so that's the basic overview, so let's go ahead and get this in. So this is how I've spliced into the ignition. So I've got some leads right here that I've just spliced in. We got our ignition wire, we have a negative wire right here. So I'm just going to have these little pieces just dangling off here. And now what we can do is we can add a wire and splice onto anywhere along this little branch that's sticking out here, and basically add as many circuits as we can fit on there as we need to. Now we're only going to be adding 3 relays here, so it's not going to be too much, but it's always better to have a little excess than not enough. So we're making progress on our heating install here. So turns out the switch was the polarity was opposite of what we wanted, so I wasn't able to get it to work. I played around with it about 3 hours and drove me crazy, but the conclusion is that it's the polarity is opposite of what we want here. So unfortunately we don't have the AC button, but that's okay because I got some other nice generic buttons here that I bought a bag of 20 of them, so we're going to be using those throughout the car, so they'll all be matching. And so all we have to do is push this guy right here, and we got ourselves a nice red light for heat. And this guy is spinning, as you can see here, and it's putting out the heat a little bit anyway. It's actually not too bad. So that should help out as a little booster. And what we're going to do as far as installing it, this kit comes with these nice little metal brackets here. So this is pretty cool actually. I thought these things were kind of a joke, but actually they work really well. Comes with screws, comes with 4 of these guys. They're stiff enough, but they're flexible enough, so it's just perfect for what we're doing here. So as you can see right here, we're going to just stick this thing up in here, something to this effect. I don't want to block it off entirely because it won't always be on. And this is the intake for the fan is in there, so we don't want to block it off too much. But I mean, this thing does flow through, so even when it's not being used as a heater, it still will allow air to go through. So something like that is what the idea is. And then I'll just tie it off above there, and then put a couple more of these metal brackets on the bottom. Add 2 down here, and then I think it will be braced in there nice and snug, and it's easy to get to. It's kind of an experiment. We'll see how it goes. It's kind of an experiment. We'll see what happens, and if we need to modify it later, we can always do so. It's easy access. This is very easy to get to. It's not like it's tucked away or anything. So even when everything is back in the car here, it'd be pretty easy to get to. So anyway, that's the progress on this this circuit. So this circuit's done. Let's go on to something else. And so this is our chill plate right here for our controller. This is the only thing that's going to be liquid cooled on the entire system. And below it is the actual controller. So what will happen is this will be underneath the actual controller, and liquid will be coming in from below, and then it will be funneling through and then out the other sides. Here's the chill plate installed. This is what it looks like from the underside. We've got the brass elbows coming out of it, Teflon tape secured into the aluminum plate here. This is M61 6061 aluminum. You know, this chill plate weighs 9 pounds. It's excessively heavy. I don't know why they did that, but should be pretty sturdy, that's for sure. And here's what it looks like right side up. So this is exactly how it's going to be installed into the car. That aluminum plate there is represented by the cardboard right there. And then we'll bolt it in from above with some metal brackets to keep it secure. So we got our drive shaft back from the drive line place. And so what had to happen is they actually had to cut this tube right here and then weld on a new piece right here to make this work. So this is the piece that I had right here. And then they added a U-joint and they cut this and they put another piece to match it. The only way they could get this piece to properly line up. And they also did a nice job. They actually painted the whole thing too. Checked everything else, made sure everything else was okay. So everything else checks out and it's perfectly balanced. They put new weights on it right here. See these right here? So it's been totally balanced. So we have a nice, basically like new drive shaft, and we obviously have a brand new motor here. So we should have a nice smooth powertrain now. So what we're going to do now is we're going to go ahead and install this guy in, because we know that this is a fixed point and we know that's a fixed point. And we don't exactly know if this is shifted. It probably has, and it's not going to matter anyway because our motor is totally flexible in relationship to however this transmission was before. So we know it's approximately. I got it kind of lined up here. This is approximately where I think everything is going to line up. This is where this piece used to slide in to the transmission here. That's approximately, and then the joint is right about here. So I got it kind of lined up. It's going to be something like that. So that's what I'm estimating. So what we'll do is we'll put the drive shaft in, and then we'll go ahead and use our transmission jack that I just bought and lift up our motor, get that in position, and connect it to our drive shaft. We should be able to slide that in, lift it up, and then slide it in. And then it will be simply a matter of taking some measurements. And we have our mounting holes here. There's 4 of them on the motor. And then we know that that bracket right there is approximately right in about the same position. So we know that that bracket goes into our chassis. So it's really just a matter of making that bracket fit our motor, and having a bracket here on the motor, and then somehow making that custom piece to make this go to that, basically. So some sort of L-shaped deal. We'll have to do something custom right there. So that will be the second part of the hardest part of the whole project. First part was getting this to making our drive line match up with our motor. That was part 1, and part 2 is making our motor now mount to our car. So that's what we're going to do. So let's go ahead and do it. So our drive shaft is installed. Went in pretty smoothly. It's only 15 pounds. Pretty easy to get it up. One person. No big deal. And now we have our transmission jack here, and we have our motor mounted on it. I think this is I specifically bought this transmission jack for this purpose, so I think it's looking pretty good right now. So all we can do now is we can easily maneuver this around, get it in position here, though it looks like we might be a little bit tight. We might have to lift the car up a little bit more, or maybe come in from the front. But we could actually probably rotate this motor actually and probably get these contacts out of the way. But it looks like we'll be able to make it here. We're pretty close. And so what we're going to do is we're going to use this. I think this is going to work really nicely because it's easy to maneuver around, and it's more of it's a scissors jack, so it's going to be able to position and just be able to keep it stationary for a while, because we're probably going to get this in position today, and then we'll probably come back tomorrow and actually do the measurements on all the stuff that we need using our brackets and everything, and try to figure out how this custom bracket's going to go together. But for now, let's go ahead and get this in position and get it connected to the drive shaft and see where we are. Okay, so we're under the car here. I'm lifting it up right now. And so, yeah, as you can see, there's a lot of room above, but there's a lip right here, and I knew that was there. And I think it's going to just barely clear that lip. And then, of course, it will actually reside a little bit higher up. So this is probably about the center line right here. That's about where it's going to be. So it'll probably reside just above that. So I think we're going to have, it's going to be nice and snug, but I think it's going to make it. We are going to have to rotate it because there's some wiring sticking out here that I didn't know about when I got on the original sketch or the original diagram. They don't show that wiring coming out. They just show the motor. Same thing with this back here, though. Other electrical connections, they don't really show that sticking out so much. So we'll probably have to just twirl this around a little bit, rotate it around a little bit, and then we'll be able to lift it up further. So I already got it all the way to the back there. It's hitting our battery tray in the back. So can't go back much further. And it looks like we're going to be able to make it, though, because this is our connection right here. So we should be able to slip it on in there. So let's continue on. Okay, so I got the motor pretty much where I want it. It's as far as fore and aft, it's right on it right now. So this is where it's going to rest. It's a little bit lower. The jack can't go any higher. It's hitting the frame of the car. So I'm going to have to put some sort of shim or something between the motor and the jack here to get it up a couple more inches. But in the front here, I don't know if I can get around here or not, but it's looks like we got about 2 inches or so of clearance there, so that's perfect. And it fits in here fine. This is where it's going to be as far as 4.5. So now all we really have to do is take an angle measurement on this drive shaft here and determine how many inches up we have to go from here, and then we can just simply add those inches to our bracket going upwards, and we'll figure out how to shim it later, as far as between the motor and the transmission jack. And this is where our manual transmission mounting holes are at. So it's really pretty close. You can see it's pretty convenient. We just have to have some sort of L-shaped or U-shaped kind of bracket coming down that turns to an L and then goes into here. I mean, we could probably use that existing U-shaped piece possibly and put something in, but that's what we're going to have to figure out. So all we have to do is figure out the bracket, and then the second of the hardest part will be done. Here's what's looking from this side. So I figured it out about 2.5 inches up, and there's about 3.5 inches of clearance. So it looks like we're going to have plenty of, and that's from the high spot, the electrical connector top of the motor. So there's still going to be like an inch. So we got plenty of room. Should work nice. So I've gathered some material to make our bracket here. This is some 1.5 by 1.5 1/8 inch angle steel. Actually, this is some remnants that I had lying around the house here from 12 years ago. Didn't know what to do with it, and now I got a use for it. So how perfect is that? I don't even have to go out and buy any material. And so what we're going to do is we're going to cut a 6-inch piece off right here, and that's going to be our bracket. So this is I'm showing, this is the bolts right here. The only thing I've had to buy is bolts. That's everything else. I've got stuff right here, so I didn't have to buy anything else, which is really cool. So this is approximately where it's going to go into the motor. So this is going to angle into our motor, and then these bolts right here are going to be right about in this location. And what I got here is I got some other steel. I just found this in the shed actually. It's not. I didn't put it there. It was already there. So previous owner left me some scrap steel. So what we have here is about a 3/16-inch plate right here. So we're going to basically cut 2 pieces and then have them side by side. So it's basically going to be a 5.5-inch piece coming off of our angle here, and that's going to go into our existing bracket right here. So only problem is that I'd like to use the existing bolts, but as you can see, it's not gonna go through enough. So what we're gonna do is we're gonna have to take these out, probably cut them back, and then probably drill them out, and then we're gonna increase the hole size, and then what we're gonna do is we're gonna put a longer threaded bolt going through just to be consistent. These are all 3/8 by 16. So and these are 1 inch length bolts here, and then so we'll be able to put new bolts in, and that will be significantly higher than the other ones. And then so basically just using 6 bolts here, we should be able to fabricate our custom bracket here. So here's all our parts, completely cut, completely drilled, ready for assembly. Here's our assembly put together. It's looking pretty good. We just tighten it up a little bit for now. Oh, also I upgraded the bolts here are 1.5 now instead of just 1, because 1 wasn't quite cutting it. It wasn't quite long enough. So I went ahead and bought 1.5 and inch, fortunately. So I had those as well. It's quite a stretch there, so you have to make sure you got enough long enough bolt coming out there. We're going to be adding lock washers as well, so I want to make sure we have enough threads on there. So always make sure you got more. You don't want to be pushing it too tight. So it's looking pretty good now. So I think we got it tightened up. This is 9/16 is what is required for that, to put that together. And now let's go ahead and install this in our car and see how it fits. And then if everything looks good, we'll take it back out and weld it. Well, first we'll sand it a little bit, weld it, and then we'll paint it and then install it the next day. Okay, so we had to adjust it a little bit here. Had to file out these holes a little bit outwards in this case, because I didn't quite it has to be, it's a pretty tight tolerances here, so you have to get it pretty tight, pretty accurate. So other than that, it went right in, so no problem whatsoever. I checked all the dimensions up here. Everything looks to be pretty good. I checked using my level here. So I want to show you one of the reasons why we're going to weld this mounting bracket here as opposed to not, and also why I'm only going to weld certain parts of it. So as this is kind of a experiment car, I want to have the ability to possibly change the motor out in the future, to upgrade the motor to a bigger motor. And if I do so, they might have different mounting holes. So I don't want to, although this is customized for our motor we have, which is all well and good, it's going to work for our motor we have, but what if we want to change the motor? So the thing is that I don't want to weld all of this together because then it would be too permanent. So what I want to do is I want to keep this piece right here, because this is kind of the unique part here. I mean, this is the unobtainium as far as I'm concerned right here. This custom the piece that came with the car. So we don't want to weld to that. I think we're going to have just our bolts going through with lock washers. That's what we're going to have for that. But for the rest of it, I think we can go ahead and weld just for extra security. So one of the main reasons why I want to do any kind of welding at all, because I think our bolts are going to be, it's going to suffice. But I just want to show you one example of, like, for example, if this was a 4-inch plate right here, as opposed to a 2-inch and another 2-inch, this is what would happen. So if these bolts came free a little bit, but not all the way off, what you would have is you'd have like this kind of movement right here. You'd have, that's the maximum amount of movement you would have right there. So that would be it if that was a single plate. But because these are two separate plates, what happens now is you get this crap. So you get all this crazy movement going on right here, which we definitely cannot have that, because I mean that would be just all messed up. You'd have crazy amount of movement. That thing would be flopping around all over the place. So that's why we're going to selectively weld. So what we're going to do is we're going to weld just our new stuff that we fabricated. We're going to weld it right here and in here, and do the same on the bottom here. And that way, that should make this super rigid, side to side. And the most movement we could possibly get when these are loose would be a little bit like that. We've sanded everything down now, so now we're doing the final assembly now. So we want to make sure that this is as perfectly square as we can get it. So it's about a little over 2 1/8 right there. And same thing on this side. Looks like we were at about 2 1/8, a little over 2 1/8. So yeah, it's about as square as we can get it within a 32nd of an inch, which is good enough. So what we're going to do is we're going to continue to tighten this down now. We got our lock washers in place. Tighten this down as tight as we can get them. And then we'll go ahead and weld. Warning, it's a horror show. I got a $100 welder. It's amazing that it can actually put down a bead though, but it does. But it also makes a lot of splatter. Now that may just be by technique, but anything's better than nothing. I mean, it's only the third time I've actually ever used it for anything, so it's as you can see, it splatters like hell, but it actually puts down some beads though. It's probably, like I said, it's probably my technique more than anything. But anyway, it's amazing that a $100 welder from Harbor Freight can actually do anything, but it does. So anyway, that is tacked in place at least, and it's bolted down for sure. So we'll let this cool. It's still a little bit warm. Let that cool off, and then we'll go ahead and paint.